Hello students, today we are presenting the key technologies of W browsing. First, let's take a look at the peer model of IE 802 and TCP/IP. There is a corresponding relationship between them. The 802.1 wireless protocol and the TCP/IP protocol are structurally similar. We can analyze them from the physical layer and the data link layer to understand their differences and connections. First, the physical layer. The physical layer is mainly responsible for the transmission of wireless signals, including different modulation and coding methods, in the 802.11 protocol. Orthogonal frequency division multiplexing is a key technology. It can improve the efficiency of data transmission while reducing interference. Under different wireless standards, the modulation methods and channel utilization of the physical layer vary. The second is our data link layer. The data link layer is mainly responsible for channel access, addressing, data frame verification, error detection, and security mechanisms between wireless devices. It determines the overall performance and reliability of the wireless network. Next, let's take a look at an overview of the key technologies in WLAN. These technologies play a crucial role in wireless communication. First is the key technology of the physical layer. OFDM is called orthogonal frequency division multiplexing. OFDMA is called orthogonal frequency division multiple access, and MIMO refers to multiple input, multiple output. In our 802.11 protocol, like 802.11a and G, use OFDM modulation. Then 802.WLAN adopts MIMO, multiple input, multiple output technology, FA, and in addition, 802.1ac uses 256 QAM modulation to increase the rate. OFDMA, on the other hand, is used in our 802.11ax, which is Wi-Fi 6. This technology is used to improve spectrum efficiency. In addition, there are several technologies at the MAC layer. The first one is called CSMA-CA, which stands for Carrier Sense Multiple Access, with collision avoidance. Before sending data, the device first listens to check if the channel is free. If the channel is busy, it delays sending to avoid data collisions. The second is RTS-CTS, which stands for request to send, clear to send. Next, there is something called interframe spacing, channel bonding, frame aggregation technology. Frame aggregation in Wi-Fi 6 combines multiple data packets into a single frame for transmission. This can increase throughput and reduce overhead. There is also BA, which is a fast acknowledgement mechanism. We will provide detailed explanations on RTS, CTS, IFS, channel bonding, and frame aggregation. Let's first take a look at the physical layer technology. In the IE 802.11 standard, our physical layer uses three different modulation techniques. The first is called FHSS, which is frequency hopping. DSS is called direct sequence. OFDM is called orthogonal frequency division multiplexing. Currently, the first two have been phased out. So, when studying, you should focus on our OFDM technology. Let's look at another concept called carrier wave. In our wireless communication, all data transmission is carried out through electromagnetic waves. And this electromagnetic wave itself is the carrier wave. But to utilize the channel more effectively, we have further subdivided the carrier wave to form subcarriers. What is a subcarrier? In our traditional wireless communication, signals are carried by a single carrier wave to transmit data. To improve channel utilization, we typically further divide the channel into multiple subchannels, each corresponding to a subcarrier. The role of the subcarrier is to transmit different information through different subcarriers, allowing our entire channel to be more efficient. To have a higher utilization rate, thereby improving our channel utilization. In Wi-Fi and most wireless communication technologies, we typically use OFDM technology for signal transmission. So why do we need to use OFDM technology? Suppose we don't use this technology, how would the signal be transmitted? In our traditional method, data might be mixed together like this convoy of different colored cars and then transmitted simultaneously. In this situation, the receiver must distinguish different information from the mixed data stream, which increases the complexity of decoding and may also lead to signal interference. So, what would be different if we used OFDM technology? OFDM allocates different signals through subcarriers, ensuring that each data stream is transmitted on a fixed subchannel. The advantage of this is that channel resources are utilized more evenly, reducing interference and improving transmission efficiency. This method is known as multi-carrier modulation technology, which is also the core principle of OFDM. Let's take a closer look at what exactly OFDM technology is. Let's explain its concept in detail. OFDM is a multi-carrier coordination technology, or in other words, a multi-carrier. Modulation technology, its core idea is to divide the data stream into multiple subchannels and transmit data simultaneously on these subchannels to improve bandwidth utilization and reduce interference. In wireless communication, ordinary electromagnetic waves themselves do not carry any information. They are merely carriers. Therefore, we need to modulate the waveform or frequency to enable it to carry information and be transmitted. In OFDM technology, we usually refer to all the waves used to carry data as subcarriers. Subcarriers are multiple independent signal channels that are orthogonal to each other to reduce mutual interference. So, the carrier wave. What is the carrier wave then? Actually, the carrier wave is a modulated subcarrier. The modulated subcarrier can carry data and can be easily distinguished without interfering with each other. So simply put, the carrier wave is a modulated subcarrier used for the actual transmission of data. But OFDM, how does it achieve the mutual distinction of subcarriers? Moreover, how do they avoid interfering with each other? Well, one of the core technologies of OFDM is to maintain an orthogonal relationship among all the subcarriers. What does orthogonal mean? For example, when the peak of wave number 1 reaches its highest point, meaning its maximum amplitude, the amplitudes of wave number 2 or wave number 3 will be zero. When wave number 2 reaches its peak, the amplitudes of wave number 1 and wave number 3 will be zero. When wave number 3 reaches its peak, the peaks of wave number 1 and wave number 2 will be zero. In other words, at any given moment, only one subcarrier is at its maximum value while the other carriers are not. The amplitudes will all be zero. It is precisely because of this characteristic of taking turns reaching the peak that we call it orthogonal frequency division multiplexing, or OFDM. This means that multiple subcarriers can transmit data simultaneously without causing interference. Moreover, this method is more efficient than traditional modulation methods because all the subcarriers can fully utilize the bandwidth without affecting each other. This also increases our data transmission, which at a rate and wireless communication becomes more stable. Next, let's take a look at how OFDM technology is applied in 5G communication systems. In the 5G network, we have a total of 52 subcarriers, which can also be referred to as channels. The bandwidth of Each subcarrier is 312.5 kHz. Among these 52 subcarriers, 48 are used for data transmission, and 4 subcarriers are used for phase reference, meaning they do not carry data. These are primarily used for phase synchronization to ensure the stability and accuracy of data transmission. In our OFDM technology, we use different modulation methods to improve data transmission efficiency. Common modulation methods include QAM. QAM, or quadrature amplitude modulation, is the most commonly used method currently, allowing for the transmission of more information. Additionally, there is also BPSK, known as binary phase shift keying. It was one of the earlier methods we used, but it has a lower data rate. QPSK, known as quadrature phase shift keying, was used in early protocols and is now rarely used. Currently, the mainstream is QAM, quadrature amplitude modulation. What are its advantages? So, it can transmit more data within the same spectral resources. For example, 1024 QAM. It can provide a higher speed than 256. This allows Comptia to increase speed by 25%. Additionally, it can have more module stacking, so its transmission capability is stronger. Now let's take a look at what EO, OFDMA technology is. It is called orthogonal frequency division multiple access. OFDMA is an orthogonal frequency division multiple access technology. It is a new technology introduced in 802.11x, also known as Wi-Fi 6, which offers a finer frequency division compared to traditional OFDM. In its frequency division, within our OFDM, each subcarrier has a bandwidth of 312.5 kHz. However, in OFDMA, the bandwidth of each subcarrier is reduced to 78.125 kHz. 712-L35 CAD. This significantly reduces the frequency. Bandwidth division. Why reduce the bandwidth of the carrier? OFDMA, by using this finer frequency division, can improve spectrum efficiency and support more bandwidth or channels. Simultaneous transmission. This improves the overall performance of Wi-Fi 6. This is the main difference between OFDMA and OFDM, and it is an important technology in Wi-Fi 6. In Wi-Fi 5, our data transmission 同样 use time division multiplexing, meaning only one user could transmit data at any given time. For example, different colors represent different users. Different users. Each user could only transmit at a specific time point, and the transmission time is the symbol time. Only one user is allowed to transmit within a unit of time. However, in Wi-Fi 6, the OFDMA technology breaks this limitation of time fragmentation, optimizing the use of resources by dividing the bandwidth into multiple resource units. Each RU can be understood as a small bandwidth unit. By using this division, Wi-Fi 6 can support multiple users transmitting data simultaneously. The core of Wi-Fi 6 is to improve the efficiency of multi-user communication, addressing the weakest point in Wi-Fi 6 technology, which is the ability to support multiple users. That's all for today's sharing. If anyone is interested in Huawei certification or Huawei-related topics, feel free to leave a comment below my video.